When it comes to hypersonic missiles and futuristic aerospace systems, similar topics always make the news. Yet, behind complex technologies and impressive speeds above Mach 5, there are significant problems. One above all is how to efficiently exploit these vehicles without turning them into huge, expensive, and difficult to manage objects. This is precisely where the work presented in recent days by Lockheed Martin and GE Aerospace starts, which have tested a new solution in the field of hypersonic propulsion, very promising apparently. The aim is to combine two technologies that until recently seemed more theoretical than practical, namely the rotary detonation engine, enriched with an air intake developed by Lockheed Martin. The rotary Mach engine is powered by liquid fuel and is developed by GE Aerospace. Instead of a continuous and soft combustion, this system uses supersonic detonation waves that spin inside the chamber, maintaining high pressures and a more effective thrust. According to the engineers, efficiency can increase by about a quarter compared to traditional systems, with a more compact and lighter motor. On the other hand, the experience of Lockheed Martin comes into play, which has designed a tactical air intake capable of adapting to very different flight regimes. In practice, at extreme speeds, air does not simply enter the engine, but compresses, generates shock waves, and can become unstable within a few moments. That's why managing these flows reliably is one of the most difficult challenges of hypersonics. One of the historical limitations of hypersonic missiles is the initial phase of flight. In fact, ramjets only work well when the missile is already very fast, forcing the use of large rocket boosters for launch. Boosters that weigh, cost, and reduce operational flexibility, and the tested system aims precisely to reduce this dependence. In fact, it would like to achieve a more gradual transition between the various phases of the flight and, consequently, an increase in the overall range. Fewer components, smaller engines, and greater autonomy also mean potentially lower costs and simpler production, a detail that is far from secondary given the complex technologies at play. That said, we are still in a testing phase, but in the future, hypersonic motors will have to be high performance and sustainable to really be worth the production costs.